Okay, so welcome to the question. So we have the question 8. We are given the resistance, internal known, inf unknown, and then we're given the parallel resistors. We have, as you can see, we have required to calculate ampere, velocity, and that. So that's just a highlight on the problem that we have to solve. So you can see that now we have to solve it when the switch 1 is open, so which means there'll be current going through the R3 resistor, and then we're given the new value of ammeter reading required to calculate inf, and then yeah, so that's what they want us to do. So S2 there now closed, that is for the last question, and you have voltmeter there, and whether says it increase or remains the same. So we're going to use Ohm's law to solve most of these problems, almost all of them. So here we go. Prerequisites for the problem, what is required to solve it. You have here what you would say Ohm's law and its application, and then you have the Ohm's law, which states that it is potential difference is equals to current times resistance, and then I there is V over R. And then if the math simultaneous, because remember that we have Ohm's law, ratio, math, then you must know simultaneous equation. So that is if you have two unknown values, so you'll have to use simultaneous as long as they are related, you know. Then we also required to solve for power. Power is I, which is current times potential difference, but you can also check on the formula sheet for different values of power depending on what you have. So those are the requirements, Ohm's law, ratio, and so forth. So state Ohm's law. Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So that is it. Make sure you memorize it correctly. They want it exactly as it is. So question 8.2.1, you'd see that here we have potential difference there at the resistance whereby it's 3 ohm. So that resistance there is given, and then potential difference at the 3 ohm is the same. Since that in parallel the potential difference are the same, actually same thing. So you find that the potential difference there for the 3 ohm and the one on the other side, which is in this case we have 2 ohm plus it's like plus potential difference at 5 ohm. So those are in actually series, so you'd see that you have to find the values there. Now you find that the total resistance in this case will be 7 ohm, because in series you just add. It's the simplest you can do. So adding those gives us 7. Now potential difference, again we rely on Ohm's law, which is current times resistance, but in this case the resistor external is parallel. So you can see that here we have 2 ohm and 5 ohm, making it 7, as you can see. Then we go back there, we also have ammeter reading, which is 1.5 ampere. So given I is, in this case you can see 1.5, and we can go back to the question and verify. Now we have potential difference, which is a formula again will be we actually rely on the Ohm's law most of the time. So we write it repeatedly. So we're checking here, we want the potential difference there is the same as the potential difference on the other side. So electron is flowing there and at 1.5 meter, and then you have current and I, and then you have 1.5, and then you have the resistance total 2 plus 5, making it 7. So you have 7 multiplied by 1.5, giving you 10.5. You can verify the calculations in case I made human error. And then the current flowing there is 10.5 volts, which is parallel to the 3 ohm resistor. So remember, the voltmeter is on the 3 ohm, so you need to know the potential difference there, because we already know the resistance. So coming back again, and you know that V at 3 ohm in this case. So now we apply the Ohm's law. The current is potential difference is 10.5. So having calculated that from the potential difference from the resistors and the current passing through. So that's it. So you find that now we have 10.5 volts on both sides of the parallel passage. So 8.2.2, we now read to know the reading of the ammeter A2. So again, we know that voltage at 3 ohm is going to be 10.5. So that's the potential difference. So that's what we know. And we also know that potential difference is current times resistance. So current is going to be potential difference divided by R. So that is 10.5 divided by, that is 3, giving you 3.5. So that is, we now need to know the current passing through there. So you see that the current passing through there is 3.5. So now we have two paths. We have one path there given is 1.5 ampere, that's the current, and the other path on the 3 ohm is 3.5. So what we have to do, you can see we need to add the path together, because the current in is equal to the current out. So you find that the current going that side and the current going that side. So there's electrons. Remember, the electricity is the transfer of electrons from a place of low potential to high potential. So that is 1.5 plus 3.5, giving us 5 ampere. So that's it. Now we have the current reading there, which is 1.5 ampere plus 3.5 ampere. Okay, so that gives us 1 plus 5 plus 3.5, that is 5.0 ampere. So that is it. Now we move on to the other question. So that's our answer. So we go to there and we indicate. It's very necessary that you write down the information so that you know what values to use. So question 8.2.3, power dissipated at 3 ohm. So we go once again to the power formula. So we want to know their power will be power that is going to be, that's the standard equation, but you can change it with Ohm's law to give you different values. You can check that on the formula sheet. So that is, current is 3.5, potential difference, obvious, I think it's the previous value 10.5 V. So we go there 10.5, we fill in 10.5. So that is 10.5 there, multiplying the 2, current times potential difference, gives us 36.75. Now 8.3, we need to find the electromotive force, the EMF. So that is the total potential difference that the battery can provide if not supplying the circuit. So we have potential difference internal there, which is R. We don't know that one. And then we need to know the potential difference external. So the potential difference external, that we need to know that current, and then we have resistor external plus the same current with the internal resistance. Now you can see that we need to find our current multiplied by, which is the potential difference. So you see from this, that's the same equation like the previous one. And then now we need to know total resistance parallel. So we have parallel, we have this is 3 ohm, and there we have 7 ohm. Remember that it splits into 2 parts, so each part has different equivalence resistance. So the equation for parallel equivalence will be product divided by sum. So you can see that that would be it's product over, not sum over product, it's product divided by sum. Okay, so that is the sum there. So we look at the sum. So we have 2 resistors there. The one there, total equivalence is 3, and the other is 7. So we'll have in our product, that will be 3 times 7, and then then we have 3 plus, so that has to be plus 7, so that will give us 21. That will also give us 10. So 21 divided by 10, overall I think it's gonna be 2.1. So that would be 2.1 ohm. So that is resistor external. So knowing the resistors external, because now we have, remember at first we had 3 values: M, electromotive force that we didn't know, a resistance parallel that we didn't calculate, but we have all the values. Then we are left with the internal resistance. So that's either we have that is 5 ammeters. So we have 2 situations. We have the first situation there whereby we calculated that the current is 5 meters, and then we have second situation where it's 3.64. so the second situation, current after some certain changes, so the electromotive force doesn't change, remember, but then changing the resistance and other factors will affect the value of the current, and maybe even potential difference on different points of the circuit. So we need simultaneous equations. So you see from the beginning, I did emphasize that before you solve a problem, you should know the tools that you need to use, So you have to think hard on situations like that. So now you have electromotive force there. We need to simultaneous to find the internal resistance. Okay, so we need to find internal resistance, and we're going to use simultaneous equation. So we have there, that is 5 multiplied by 2.1, so that is our total resistance, that is 21 divided by 10, 2.1. And then we have another situation whereby it's 3.64, which is our current, and then our resistance in that case, that would be 3, so 3.6, and then our R, we don't know it, so we make that other one equation 1. Okay, so electromotive force doesn't change, so the equations can change in different, but then equivalent to electromotive force. So then we have there 5 multiplied by 2.1 plus so we have to equate those equations, plus 5 R, so that would be 5 let me just write it correctly, that would give me 3, so which means those equations are equal. Remember that they are equal to electromotive force, so which means the 2 equations are equal to each other. So that's the idea. So being equal to each other, then we have to group like terms. In this case, we have 10.5, that is 5 times 2.1 plus 5R, and 3.64 times 3 gives us 10.92 plus 3.64R. So now you can see we have constant and the R values, and then now we have to group like terms. So you can just take the smallest to the biggest. So you can see the 5R and 3.64R, we can just transpose 3.64. So that is when we group like terms. Now this is it. Now we have, in this case, remember we were solving for R, so we make R the subject of our formula. So when R is the subject of our formula, we have the 5R minus 3.64R is equals to 10.92 minus 10.5. Then we come and simplify, find out what the difference makes on both sides. So we find that on the left hand side we have 1.36R, on the right hand side we have 0.42. Now R will be 0.42 divided by 1.36. So that gives us the value using the calculator there. That will give us 0.308588. Yeah. So coming back, we move on. Now we need to know the potential difference internal. Now that we know that it's IR. So remember that our current there was given like on the previous value. So it's 3.64. Okay. Multiplied by 0.30. We didn't round off the 30 because it's not our final answer. So giving us our value there as 1.30. 0.24. So that would be the potential difference. Now we now have the electromotive force. Electromotive force is potential difference external plus potential difference internal. So you can see that potential difference external was calculated, and we find out that our looking for the value potential difference internal, that is 10.5. Is that 10.5? Let me just confirm. And I think we need to use the latest value. Well, that one is the old one. The latest value based on the information given. So when looking for it, just going through the script and look for our value. It's 10.92. Remember that is current times resistance. So it's 10.92 plus that is 1.124. So 1.124. So adding that together gives us a value of 12.044. So that is it. So running up to 2 decimal values will give us 12.04. So that's our final answer. So that's our electromotive force. The unit there is V for voltage. And yeah, so that is probably the answer of 8.3. So we go back on the other question now. 8.4, we need to find out like when S2 is now closed. You can pause and just go through the question and find out the information that we have. So R increases to 7 ohm. R also increases because remember that it's from parallel to single path. So it means that instead of the one going through 7 ohm and 3 ohm, now you have one path going through the 3 ohm in that case. But we'll have to look at this question that is in series. So when it moves from parallel to series, do we expect an increase in the current since the path is no longer split between the two? So S1 is closed and S2 is open. So we go back. I just want to verify something. V will give let me just double check. We have S1 closed, S2 is open. So where's the potential difference? Potential difference at S2, right? So at S2, if it's open, then the potential difference will not read anything because there's no path going through there. So you can see that S2 is open. Okay, so when S2 is open, then they will read nothing because remember that there's no electrons passing through, so you have no values. So that question probably has an error. You can double check it. The voltmeter will not read anything. They will not read anything. Yeah, so that's how I summarize the problem. I think we're done. So I don't know how they'll check that, but so voltage is on 3 ohm, and then S2 is on switch 2, and then no current flow, and then potential difference multiplied by potential is current multiplied by R. 0 times R give you 0 value. So we don't have value on the options, so there's an error on that. So let's come back to the homework. So this is your homework. You have this problem there. You have the internal resistance there, 0.1. You have 3 resistors that are equal. You have to define amp, and then you have switch 1 there. Then you follow the instructions. So you've got current given there, which is ammeter reading right now. So you have ammeter reading R3. There's 2 ampere. Then you have to find the energy dissipated in 20 minutes. Inf also on 8.2.2. So that's your homework. I hope you all the best. Don't forget to subscribe. Thank you.